Hello, in this video we will talk about AIC and BIC. So both AIC and BIC are criteria to evaluate the model performance and parsimony. So because the model, if you use more parameters, usually get the better performance in estimation. But if you, for example, you have 100 observations and you can use 100 parameters, but this kind of model is meaningless because this is overfitting the data and not good for the new data have not seen. So in this respect, we will get some penalizing part fault evaluation. So this comes AIC and BIC. So which means we will get the better model for performance, but at the same time we will try to make the model as fewer parameters as possible. And the formula for the AIC and the BIC are quite similar. AIC equals the deviance plus 2 times P. P is the numbers of parameters. And here deviance is negative 2 times the log likelihood. So the deviance is like the variance. So this is the measure of lack of fit of the model. So usually deviance is a positive number, but lower is better, because log likelihood is the negative number. So deviance is positive and lower is better. So you can see AIC equals to minus 2 log likelihood plus 2k. K also the number of parameters. And the BIC had the same first term as AIC, but here we use the 2k times log n. So the BIC will get even stronger penalizing for the model if you use more parameters. So here is the log n. N is the sample size, and here this term usually will larger than 1, right? And the log likelihood depends on the model given the data. And the deviance is same as variance, or the measure of lack of fit for the model. For linear regression model, for example, AIC equals n times log SSE divided by n plus 2k. So here SSE, the sum of squared error. If you remember the linear regression, sum of squared error is the summation of each observation minus its predicted value from the models and take a square. So this is sum of squared errors. So here's the mean squared error, then take log function. And for the logistic regression model, log likelihood calculation is the sigma for all the sample. Then for each sample, each observation, we will use the yi. This is the real class label 1 or 0. So if yi is 1, 1 minus I is 0, right? So here yi times the log and the probability of yi from the model. Then plus 1 minus yi times the log of 1 minus the probability of yi. So if yi is 1, here is the probability of 1 and this is the probability of 0, right? Because the logistic regression is to model and predict the class label 1 or 0. So this is the log likelihood calculation in the logistic regression. So this is 3, 1. This 2 is the same thing, right? Because the deviance is log likelihood times minus 2. So thanks for watching.